right, here's another integration by parts example, and this actually I would say is reminiscent, don't let me make you nauseous, I'm going to scroll back up, of number 4, where we don't actually have a product, we just have a function sitting around, but it is a function I don't know the antiderivative of. Okay, so sorry for all the back and forth. I don't know the antiderivative of natural log x, so I'm kind of stuck on that. Even if there's not a product, you can you can always think of something as multiplied by 1, so it is always possible to play around with product rule. It might not be helpful, but it is always possible. So if we think about lie 8, that says we should be prioritizing natural logs as our u, and here that should be extra obvious because if we go over here to dv and we write down a natural log of x, we're being very silly because if we knew how to anti-differentiate natural log x, we would just answer this question and not do any by parts. So this is going to be our split. The derivative of natural log x is a 1 over x. The antiderivative of a dx is an x. So we get... what do we get? We get u times v, x natural log x, minus the integral of v du. Ooh, and I was bad. I didn't write my dx on that. This actually works out beautifully. X times 1 over x is just 1. So we're really just looking at the natural log of x integrated gives this, which means the integral of the natural log x dx is equal to x natural log x minus x plus c. So not such a terribly hard one, but just to remind you that anytime you hit something like this with inverse trig or logs, making that a u is a really good idea, even when it doesn't look like it's a product. So still could help out. I feel like I'm being bad again, and I don't have much in the way of examples of evaluating of definite integrals. So let's go ahead and just sneak that back in here. Let's use a different color so that you can see it. Okay, so let's say we were asked to do this from 1 to e. Those seem like good candidates for plugging in. So again, this isn't anything too crazy. The limits of integration just stick on the integral after you go through by parts. And then you just have to remember that they also apply to that u times v that gets spit out. So when we're all done, we can ignore the plus c. You can include it if you want to, but it's just going to drop out when we do f of b minus f of a. We would get this. So we would have an e natural log e minus e. And then we would subtract off 1 times the natural log of 1 minus 1. And as usual, I absolutely expect you to know that the natural log of 1 is 0 and the natural log of e is 1. If you feel like you're memorizing that, you need to go back and do even like 5 minutes of reviewing on what the natural log actually does. Because that shouldn't be something you know because you memorize it. It should be something you know because you know how natural logs work. So do it if you feel like you've forgotten. So really, I'm ending up with 1 times e, which is e, minus e, oh, this is going to be really nice, minus -1, so plus 1, which is 1, which means if we look at this natural log function, from 1 to e would be just shy of 3. The area that we're getting right there is exactly 1. Kind of cool. All right, thanks for watching.